Welcome, dear viewers, to this new video where we will learn step by step how to build a robot car that can be controlled remotely via Bluetooth and a smartphone app. We will start by building the robot, then electrically connecting its components, and then we will program the Arduino on it, and then we will develop an application using the MIT App Inventor tool to control the robot remotely. So don't forget to like the video, and subscribe to the channel. This video is an application of what we learned in the previous video about the HC-05 HC-06 Bluetooth module. You can visit this video via the link. The project works as follows. We have this smart device on which we will install the app, then we have here the robot with the Arduino and the Bluetooth module. When pressing the forward button, an F signal or information will be sent. This will be read by the Arduino board and encoded and thus translated into a command for the robot to move all wheels forward, and so the robot will move forward. While pressing the backward button, a B signal will be sent to the Arduino, which will then encode it and give a command to the motors to move backward, and thus the robot will move backward. When pressing the left turn button, an L signal will be sent and understood by the Arduino, which will then translate it so that the right motors move forward, and the left motors move backward, thus turning the robot to the left. While pressing the right turn button, an R signal will be sent to the Arduino, which will understand and translate it into changing the motor movements. The right motors will move backward, and the left motors will move forward, thus turning the robot to the right. After explaining the project idea, I designed its parts. As you can see, I created this design in Autodesk Inventor. I designed these mounts, which will be used to fix the DC motors to this board. This board is a plexiglass board, this transparent glass. After finishing the design of the DC motor mounts, I printed them using a 3D printer. Then I cut this plexiglass and removed the adhesive cover on it. Then I marked the places where I will make holes to fix the components. Then I made the holes. After that, I added these threaded inserts inside the printed parts so that I can fix the screws directly. I will heat them and then push them inside the 3D printed part. Then I started attaching these mounts to the board. Then I installed the motors, using the appropriate screws and nuts. To pass the wires, I made a hole in the board. Now, I will install the Arduino holder on the board so I can fix the Arduino board. Then I installed the battery, securing it with these plastic straps. I also labeled the wires so I can distinguish between them, writing the name of each motor on its corresponding wire. Then I installed the controller corresponding to Arduino. Then I added the motor shield, this Adafruit motor shield. Now I will start the electrical installation. The plan is as follows. I will connect the motors to the motor shield, and then connect the battery. Now, I will connect the battery, adding a power switch. I will fix this power switch to the frame. Then I added the wheels. Before adding the Bluetooth module, I soldered these pins to the motor shield so I can connect the Bluetooth module directly. The pins on the right are for transmission and reception, while these pins on the left are for the power supply. I also soldered them. Then I added the Bluetooth module, connecting the transmission and reception wires, and the power supply wires. Then I fixed this module to the frame using this adhesive. Thus, I have finished preparing and assembling the robot completely. After assembling the robot mechanically and electrically, I will now program the Arduino board. The program is as follows. We will need this library AF motor. You can find the library by clicking on this button in the Arduino IDE, then searching for Adafruit motor shield and installing it in the program. I started by defining these objects motor 1 to motor 4 by giving each motor or object a parameter. This number means the connector associated with the motor. For example, motor 4 is connected to connector 4. Then I defined this variable command of type char. Then in the setup function, I defined the baud rate for data transmission sent via Bluetooth and received by the Bluetooth module, and then sent sequentially to the Arduino. Then I set the speed of the 4 motors to the maximum 255. Then in the loop function, I first checked the data flow, and if it was correct, meaning the data is flowing, I read and saved it in this variable command. Then I tested this variable command, and if it equaled F, meaning the F message was sent, I called the function forward. The function forward, written here, commands all 4 motors to move forward. If the sent message equals B, I called the function backward. The function backward commands all motors to move backward. In the case of sending the letter L, I called the function turn left. The function turn left commands the right motors to move forward, while the left motors are commanded to move backward, thus turning the robot to the left. If the letter R is sent, I called the function turn right. The function turn right, defined here, commands forward for all left motors, while the right motors are commanded to move backward, thus turning the robot to the right. If the letter S is sent, in this case, all motors will stop by calling the stop function. This function stop, defined here, releases all motors. As you can see, this program is easy to understand. I will now upload it to the Arduino board, and then I will develop the application that communicates with the Arduino board. When uploading the program to the Arduino board, the Bluetooth module must be disconnected, meaning the transmission and reception wires should be disconnected. This caused me some problems, so I recommend disconnecting them. After uploading the program to the board, you can reconnect it. I will now start creating the application to control the robot using this tool MIT App Inventor. If you are interested in the details, you can visit the previous video I made on the basics of building an app with this tool. I will now start a new project. and name it a Robot Car Controls. Then I will change the screen size because I am using a tablet, and I will split the screen so I can place the components inside it. I will add horizontal arrangement from this window. Then another horizontal arrangement, another vertical arrangement, and then table arrangement. This table will allow me to split the screen horizontally and vertically. I will give it 3 columns and 3 rows. For this table, I will change some settings, like the color of this horizontal arrangement and the height to 150 pixels. Then the width to take up the entire available width. Then I will go to this vertical arrangement Then I will need a list picker, which allows me to select the device to connect to via Bluetooth. I will add it here. I will change the font size, then the height to 150 pixels, then the width to take up the entire available width. Then I will change the text to select device. After that, I will choose an image, which allows embedding an image here. As you can see, I changed it to monitor size to see it clearly. In this image, I will change its settings to 150 pixels. Then I will choose an image and add it here. Then I will need a label. I will change its settings. I will change the text and color as well. Then I will need buttons. I will change the name of this button to forward, then I will choose an image. I have already prepared the images. I will change the size, adjusting the height and width to 180. I will do the same for this button. I will change the name to left button. Then I will choose an image. And similarly for this button. Then I will add an image to add the logo. To make these components appear in the center, we will change the screen settings. I will change the name to Robot Car Control, then Center. In addition to all these components, I will need a Bluetooth client to be able to connect via Bluetooth. I will find this in the connectivity window, then Bluetooth client. I will add it. It is non-visible, meaning it does not appear on the screen. After finishing this interface, I will now write or develop the code that controls all these buttons and other components through blocks. I will start with the Bluetooth part. I will go to List Picker, then List Picker. Before picking, again, List Picker. Then I will go to Bluetooth Client, then Bluetooth Client. After that, meaning after selecting the device, after picking, I will go back to List Picker, then to After Picking. I will first need to ensure that the device is selected. Again, Control. If statement. Then call Bluetooth Client 1.connect address. This will return true or false. Then I will go back to List Picker, then List Picker 1.selection. If it is true, meaning a device was selected for connection, it will change the text on the label and also its color. I will now go to Label, then set label 1.text to and add text. For example, connected. I will copy this again, and then not connected, meaning in case of no connection. In addition to this, I will change the background color to green. I will copy this again. In this case to red, meaning in case of no connection. Thus, I have finished the Bluetooth connection part. Now I will develop the button control part. I will go to one of the buttons, for example, forward_ button, then when forward_ button to touchdown, meaning it is pressed. In this case, I will check if the Bluetooth is connected or not. Again, using an if statement, if Bluetooth client that is connected means the Bluetooth connection is correct. In this case, I will send a message. In this way, an F message meaning forward will be sent. Then I will copy this again. Now, I will need to reverse this. I will go to button again, then when forward_ button touch up. In this case, I will send an S message meaning stop. Thus, when the button is pressed, the robot will continue moving forward, but when the button is released, it will stop. I will repeat this 4 times, copying this block and copying this block 4 times as well. Then I will change the names to backward_ button, meaning when the backward_ button is pressed, another letter will be sent. In this case, we will send B. Then for the left_ button, we will send an L. Thus, I have finished the logic behind all the buttons and components of the application. As you can see, the application is now ready and can be downloaded. After I finished developing the application, I downloaded and installed it. If you are interested in the installation method, you can visit the previous video where I explained it in detail. Thus, we come to the end of today's video. I hope you enjoyed and benefited from it. Don't forget to like the video and subscribe to the channel to stay in constant touch with all new updates. Until next time, stay creative.